everyone. Let's talk about the sets of numbers that we have dealt with over time. And I think it actually makes sense to start down here at the bottom. So what I'm going to do is start down here and say the most specific and let's say smallest number set, still infinitely large, is the natural numbers. And the natural numbers are 1, 2, 3, 4, 5. These are also called the counting numbers. So the natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, and they go on forever. So 1 to infinity. Okay? No decimals, no fractions, just 1, 2, 3, 4, 5. And when you first start learning about numbers, you start counting things. We call these the counting numbers. And then it's time to clean up and put all your blocks away. And then we introduce the concept of zero. And when you introduce the concepts of zero, now you have what are called the whole numbers. Okay, so the whole numbers are 0, 1, 2, 3, 4, and they go on forever as well. So the only difference between those two is the whole numbers have 0 in them. So what else? Let's see. We start off with the positives, then we throw in 0. Hey, what about the negatives? If you throw in the negatives, those are called the integers. And the integers are whole numbers and their opposites. So like -3, -2, -1, 0, 1, 2, 3. Again, it goes on in both directions forever. So whole numbers and their opposites, those are called the integers. What else can we do? Let's see. We take away things. What if we break things and we have fractions? If you have a fraction of integers, those are called the rational numbers. So rational numbers are fractions of integers, and I'm going to write this more specifically. These can be written as a fraction. Now that means they either terminate or they repeat. So rational numbers are numbers like 2/3. That's a rational number, but as a decimal, it goes on forever, 0.6 repeating. Or 1/2 as a decimal is 0.5. Those are rational numbers. They either have a pattern or they just terminate. Okay? If they don't have a pattern and they don't terminate, then they're a special type of decimal called an irrational number. And the most common irrational number, the example you usually think of is pi, 3.1415. It goes on forever and it doesn't have a pattern. But there's lots of other ones in math class we use, like e. That's a really popular, common irrational number. Also, the square root of anything that's not a perfect square. So like radical 2. That was maybe the first number that was proved irrational with consequences to the person who did it. They killed him. Radical 2, you could also say radical 3. Radical 4 is not irrational because radical 4 is 2. So radical 5. Any perfect square or any radical that's not a perfect square is an irrational number. So we see a lot of those, but we also have some special ones like pi and e, a couple other ones. If you put the rational numbers and the irrational numbers together, so combine that set, this is called the real numbers. The real numbers. And the real number sets are composed of all the rationals and all the irrational numbers. And almost everything we have done in school up until this point has dealt with the real numbers. So what's not a real number? An imaginary number. Imaginary numbers all stem from the idea that nothing times itself gives you a negative. A positive times a positive is a positive. A negative times a positive, negative times a negative is also a positive. Nothing times itself gives you a positive number. So we made one up. We said I. I is what happens when you square root a negative number. And if you square it, I squared, if you multiply both sides times themselves, you would get -1. So knowing those two things, we can build a whole new set of numbers where we combine the real part with the imaginary part, and those are called the complex numbers. And a complex number always has a real part, which we say is a, and an imaginary part, which is little b, I. A plus bi. All complex numbers look like that, a plus bi. That's all of the number sets that you will ever see in your math classes, and that's a big deal that you know these number sets, okay? You start off down here in math class and you work your way up, and now look where we are. We've got imaginary numbers now, and we combine them to form complex numbers. So for now, The first things we'll do is, let's just remind ourselves, I is the square root of -1. So if you square both sides, you get -1. And complex numbers are always in the form a plus bi. So if I say combine like terms, you're going to combine the real part, so 6 and 4, and then you combine the imaginary part, and we'll create a new complex number. These parentheses don't mean anything, so I'm just going to distribute, well, I should say these parentheses don't mean anything, but if I distribute the minus, -4 and minus -I is plus I. Combine the real part, 6 and -4, 6 minus 4 makes 2. The imaginary part, 3 plus 1, 4i. So 2 plus 4i. Oh, my lights just kicked off. Cool. That's the new complex number. If you add these two together, you get this one. Same thing here. These parentheses don't mean anything. They have a 1 on the outside. So -10 plus 4i. But these do. You have to distribute the negative. So -8 and plus 9i. Add up the real component, -10 and -8 make -18. And the imaginary component, 9 plus 4 make 13i. One more. Here, these parentheses truly mean nothing because there's 1s on the outside. So the real part, 3 plus 5 is 8, and 2 minus 6 is -4i. So you just add the real components and the imaginary components. You don't even really have to know anything about imaginary numbers to do these. When it's just adding and subtracting, it's literally just combine like terms. But when you multiply a complex number times a complex number, you do have to worry about it. I squared is -1. So let's multiply. 2 times 5 is 10. I times whatever 1 is I. 2 times -10 is -20, and I times I is I squared. Wait a minute. I squared, that's -1. 10i minus 20 times -1, that's positive 20. So I'll write this as 20 plus 10i. Notice, I want my answer to look like this, a plus bi. So put the real part first and the imaginary part second. But in this problem, since I squared is -1, a -20 times a -1 gives you positive 20. If you have to FOIL, 3 times 8, 24. 3 times 2i, 6i. 8 times 4 is -32i. And -4 times positive 2 is -8, and I times I makes I squared. So what can we do now? 24, 6 minus 32. So we do 6 minus 32. We end up with the imaginary part, but I'm going to have to come back to this. 6 minus 32 is -26i, and then this is -8 times -1. So -8 times -1, that's positive 8. And 8 and 24 make 32, so 32 minus 26i. Kind of tricky. One more. -1 times 7 gives you -7. -1 times 6i gives you -6i. 9 times 7 gives you 63i. And then this is where you got to be careful. 9 times 6 is 54. I times I is I squared. So this is really a -54. A -54 minus 7 more is -61. And 63 minus 6 is 57i. So -61 plus 57i. Those are just complex operations. We'll talk about division later, but right now we just need to have a basic understanding of where I comes from, how to combine like terms, and then when you get to the multiply, I squared is -1. So that's it. Make sure you get your practice done, and make sure you hit that like and subscribe.